This question is a simple question under transformer. I'll sort out the parameters as we read the question along. It says, a transformer is designed to convert a 20-volt supply. By 20-volt supply, it means that is the primary voltage of the transformer. So, sorting out the parameters, we have that Vp, primary voltage, equals 25 volts. To an output of 240 volts, output being the secondary side, Vs, secondary voltage, equals 240 volts. If the transformer is 90% efficient, the efficiency of the transformer is given as 90%. Calculate the current in the primary winding, that is the input side of the transformer. IP, primary current, is what we're calculating for, we don't know it. When the output of the terminals, that is the secondary side of the transformer now, are connected to a 240 volts 80 amp lamp, it means the output power, P out, is 80 watts. 240 volts because V out, which is the secondary voltage, is 240. So it's telling you the lamp is 80 watts and rated at 240 volts, same as the output voltage of the transformer at the secondary, right? So we know the output power, we know all the other parameters, and we're looking for the primary current, which is the current flowing in the primary winding. Since we are given the output power, if we know the input power, which is the primary power of the transformer, we can calculate the input power. So let's look for the relationship between efficiency, the output power, and the input power. The formula is this: the efficiency of any machine at all. But for this one, we are looking at the transformer. Efficiency of a transformer is power out divided by power in. Now, we're given that the efficiency is 90%. So we need to get the power in at the primary. So to make power in subject of formula, we have that power in will be equal to power out divided by the efficiency. Of course, 90% is 0.9. So if we put 0.9 here and put power out as 80, we are going to get the power in to be equal to 80 divided by 0.9. And that gives us 88.89 watts. It means the input power is greater than the output power, which is expected because the efficiency is not 100%. If it was 100%, we should be getting 88.9 at input and 88.9 at the output. But here, the efficiency is 90%, so the output should be lower than the input, and that is what we've got. Now that we know the input power, let's look for the relationship between the input power and the input current, which is the primary current. Recall that power is given as current times voltage. Since we are looking at the input power, that will be equal to the input current times the input voltage. Remember, the input side of a transformer is the primary side, so it is IP for the primary current and Vp for the primary voltage. Now, to obtain IP, we divide both sides by Vp, so that our IP will be equal to P in, which is the input power, divided by the voltage at the primary, Vp. Substituting values, 88.89 in place of power input and 25 in place of voltage at the primary, we have that IP will be equals 88.89 divided by 25, and that gives us a current of 3.56 ampere. So the primary current of the transformer, or the current flowing in the primary winding, is 3.56 ampere. Very simple. If you enjoyed this, you understood it as well, then try the simple one. This is the question. Read it carefully, choose an answer from this option, and put your answer in the comment section. Thank you for watching this video, and I hope to see you in our next video. Bye.